Alright, Purples, here's our first video of just math examples. So we're just about halfway through chapter 1, and so I just want to break down our skills so far and just give you an example of each type of problem so we can cruise through these. I'll make this super short. You don't have to watch this, don't have to go through everything, but this is a place where you can get as much access as you need to. To start, I'm going to make you look at my nice little mug right here, and if you don't like it, then you can just deal with it. That was a bad attempt at a meme joke, but here we go. For the first one, multiplying exponents. These all have the same basis, so if you're looking through these problems, you're going to see this 4, the j, the a's, and the a's with some coefficients. We all have the same basis. We said before that our shortcut was adding the exponents, and to show what we're talking about, 4 to the 5th times 4 to the 3rd would be the same thing as 5 4s, all being multiplied with each other, being multiplied again by 3 4s, and that gives us a total of 8 4s, so our final answer is 4 to the 8th. We just simply added 5 and 8 to get our totals. That means j to the 9th, j to the 10th is 9j's times 10j's, which will give us j to the 19th. I'm not going to write all those out because that's a waste of both your and my time. And then we have 6a to the 2nd times 3a to the 7th. Remember, the commutative property says I can rearrange that and have 6 times 3 times a to the 2nd times a to the 7th. And so we know from our adding exponents that I'm going to get a to the 9th, because that's 2 a's and 7 a's mashed together to get 9 a's. And then 6 times 3, based on that commutative property, gives me 18a to the 9th. So here's some examples of some different ways to multiply exponents. Let's keep moving. In dividing exponents, the exact opposite. So we have the same basis. Again, we have a y, we have an a, and we have an a. So here we're just subtracting our exponents. So if I have y to the 8th divided by y to the 5th, remember that's 8y's divided by 5y's. And if you start to look at those, we don't know the value of y, but we sure know that y divided by y is just equal to 1. 1 times anything keeps that same number with the multiplicative identity property. And so if I can just know that any time that I have y's that are connected, I can just cancel those out. And so I'm just going to start slashing there. So what we're left with is 3y's on the top, and that is y to the 3rd. So I really just subtracted 8 minus 5 to get that answer of y to the 3rd. Then if I have 32a to the 10th divided by a to the 3rd, remember that is 32 times a to the 10th divided by 8 times a to the 3rd. So I'm really rewriting those as two separate fractions. And so if I can do 32 divided by 8, that equals 4. And then if I do a to the 10th divided by a to the 3rd, that is a to the 7th, because I'm just subtracting 10 minus 7. Then if I'm mashing those together again, 4 times a to the 7th just gives me 4a to the 7th, and I'm done with my answer. So again, dividing exponents is just subtracting. Our next skill was powers of powers, and we're going to go a little bit more specified on the next slide, but it's very straightforward when you have a power of a power. Again, we're still looking at the ones with same basis, so if I give you h to the 6th and I raise that exponent to the 4th, I have my parentheses because I have an exponent outside those parentheses, and since we can't do anything in here, we don't know h to the 6th, we just know it's 6 h's, I can start to cluster those to figure out exactly what I'm looking for. So if we break that down, the first h to the 6th is just 6 h's. And then we have 4 groups of those. So if I have 2 groups, 3 groups, and 4 groups, my total is now I have 24 h's because I have 4 groups of 6. So my shortcut for these is just to multiply my exponents. So my final answer, h to the 24th, and I do that by, let me shrink some of this stuff down here, and I do that simply by multiplying my exponents. So whenever you have to take a power to another power, just remember that's clustered and those are groups. So groups we multiply, and it's h to the 6th times h to the 4th is h to the 24th. As we start to look at powers of products, that means we have products or multiplication happening and then taking those things to a power. So I'm looking at one example from our book, and I have 5 times g to the 8th, k to the 12th, and you're raising that all to the 4th power. What that means is since we have this product here, we have 5 times g to the 8th times k to the 12th, every single one of those products has to go up into that fourth power. So now that really equals 5 to the fourth, g to the 8th to the fourth, and k to the 12th to the fourth. So we go back to some of our old rules, and 5 to the fourth we can just write as 5 to the fourth. G to the 8th to the fourth, remember we said that's g to the 8th, which is 8 g's, and then we have 4 groups of those, so if we have 4 groups of 8, that's g to the 32nd power, and then we have k to the 12th to the fourth, so that's 12 k's with 4 groups of them, that's 12 times 4 to get 48. So when I take a power of a product, I'm taking everything inside of those products, so the 5, the g to the 8th, and the k to the 12th, right here, here, and here, and taking all of those to that fourth power. So every product that's connected is taken to the fourth because that 4 is outside of those parentheses. It means anything in there is being taken to the fourth power. So my final answer for that one would be 5 to the fourth, g to the 32nd, k to the 48th. When we're talking about negative exponents, they can start to look a little bit different. And so here we have a to the negative fourth, and what we're going to say is that's always going to be equal to 1 over a to the fourth. Let me rewrite that fourth so it looks like it's an exponent. There we go. And then 2 to the negative sixth is the same thing as 1 over 2 to the sixths. So whenever you see that negative exponent, that means, whenever you see this negative exponent, it means you're taking this entire exponent and taking that down to a denominator under 1. And so if it's a to the negative fourth, 1 over a to the fourth, 2 to the negative sixth, 1 over 2 to the sixth. When I start putting negative exponents into problems, I get s to the negative fifth times s to the negative second. And when I'm doing those things, then I'm still just using my same rules. So now I'm just adding negative 5 and negative 2. So now I'm ending up with an answer of s to the negative 7th. Another way that I can rewrite that, and now that I have my negative exponent, the exact same thing would be 1 over s to the 7th. IXL asks you to not do stuff with denominators, so they would prefer this number. I would accept either one as correct answers, but if it's based off what the problem's asking. If it's asking for a negative exponent, it's got to be this one. If it's asking for a positive exponent, it's got to be that one. So then if I look elsewhere and I start to get this problem too, y to the negative 6 divided by y to the 10th, all I'm looking at then is using my same ideas. I have the same base of my y's, and I have a division problem of exponents. My rules say we could subtract those things in order to get to our final answer. So now I have negative 6 minus negative 10. Remember last year from our integers that is the exact same thing as negative 6 plus positive 10. I call that the chop strategy because we simply chopped the subtraction sign and then chopped the sign of the second number. And so if I have negative 6 plus positive 10, I have more positives than negatives, so that means my answer is going to be positive. And then if I'm looking to all the ways those things cancel out, I would get 10 plus negative 6 to equal positive 4. So now my final answer in this one would be y to the 4th to answer this question right here, y to the 4th. Lastly, I just want to look at 3 IXL problems, 2 on this slide, 1 on the next. And just to recap what we're looking at, just as how we can apply those things to some of our different skills, Ms. Ringenberg gave us a great explanation as to what something to the 0 power is. If I have z to the 7th divided by z to the 7th, our rule said that whenever we divide something, we're subtracting our exponents. And we know that 7 minus 7 is z to the 0. But then we also know, based off division rules, that any number being divided by itself equals 1. So if z to the 7th, whatever number that is, it's being divided by itself, that has to equal 1. So it just goes a quick showing of why something to the 0 power equals 1. So now looking at this problem up top, I have z to the 34th times z divided by z to the 0. So we know that is z to the 34th, that's a sloppy 3, times z to the 1st divided by z to the 0. We just said that, showed why this equals 1 down below, so that really takes out that entire denominator, because if I divide by 1, that number is just going to be itself. So now I'm left with z to the 34th times z to the 1st, same bases, so now I just add my exponents, and that's going to equal z to the 35th. If I'm looking at this second problem, I have p to the 94th times p to the 86th divided by p to the 56th times p to the 0. We know that p to the 0 equals 1, so let's eliminate that right away. Now we just have to add 94 to 86, and we are going to get 10 and 18, so that's 180, so it's p to the 180 up top, divided by p to the 56th. So now we just got to do a little subtraction, and I have 180 minus 56, and looks like I'm going to end up with 124. So my final answer in this one is p to the 124th. Hopefully that helps with these two. Let's check out one more tough IXL problem, especially when you start getting those upper digits. With this last problem, this was one that was really tricky, and like it looks like a very daunting problem. But once you get to those upper levels of IXL, you're gonna start seeing stuff that looks like this. To start, let's make sure that you stay grounded and you understand what we're looking at and what we're doing. We're just looking at a bunch of multiplication up top here being divided by a bunch of multiplication down here. So let's start canceling some stuff out so we can start to make a little bit more sense of this. We know b to the 0 equals 1. Anything times 1 is itself, so it's really not affecting anything that we have. I'm also going to put a little 1 above that a and a 1 above that d, because that's a to the first and d to the first. In the denominator, let's start canceling. So c to the 0 is just 1, that's just 1, that's just 1, and that's just 1. None of those are going to play into our final answer. So let's take a look at what we have now as the numerator. We have a to the first, c to the fifth, and d to the first. We're dividing that by a to the 7th, b to the 6th, b to the first, and d to the 3rd. So I have no more c's in my denominator, and I have no more b's in my numerator. So now if I start to look at those, I'm starting to think about what else do I have in my numerator. So my numerator, or if I start canceling some things out, I know that I'll have 1a, so I have a to the first divided by a to the 7th. That's a subtraction problem, so I get a to the negative 6th. Then I have my, let's see, b's to combine down here, and so that down below I'm going to get b to the 7th. And then when I'm looking to cancel out my d's, I have d to the first being divided by d to the 3rd. That's a subtraction problem. That's going to give me d to the negative 2nd, because I'm doing 1 minus 3. So that's d to the negative 2nd. And then I still have that c to the 5th up top as well. So if I'm looking for my final answer now, again, IXL needs these with no denominators, so that means I need to turn this b to the 7th into a denominator. Let's erase everything else and get down to that one final number. Let's make everything nice and small here. So now our final number is looking like this: a to the negative 6th times d to the negative 2nd. I still have a c to the 5th up top there too, because nothing canceled there from this spot. And then that's all being divided by b to the 7th. I know that b to the 7th, or in this case 1 over b to the 7th, because it's a denominator, can be written with a negative exponent. So right now we kind of can break that into a to the negative 6th, d to the negative 2nd, c to the 5th, times 1 over b to the 7th. I know that this part right here is the same thing as b to the negative 7th, so my final answer in alphabetical order is going to be a to the negative 6th, b to the negative 7th, c to the 5th, and d to the negative 2nd. This is a really difficult problem. We'll keep talking through these and make sure that we understand how to do those. Make sure that you're breaking down into chunks that you know, cancel stuff out, add, multiply, divide, subtract, all those great things we've talked about, and combine all those skills. And then if it still is not making sense, I promise that there will not be anything this overly cumbersome on any quizzes or tests. I'm just going to make sure that you know those skills and how to get there. Hopefully this video helped, and from here I'm going to try to keep all these up and maybe trim down some times, or at least give you some places to jump so you can see some different examples. Have a great day. Hope this helps, and I'll see you later.